We're going to spend the next couple of videos looking at some VLAN specific Cisco switch security features, and we're going to start with VLAN ACLs. And you're certainly familiar with ACLs at this point in syntax and options and a couple of different uses. And the ACL we've come to know and love, though, it's got a limitation or two, and one of them, by no coincidence, is about to show up in this video. We have no problem using an ACL on a multi-layer switch in this scenario, where one host is in VLAN 10, another one's in 20, another one's in 30. We can use an ACL on that multi-layer switch to filter traffic without a problem in the world. But it can't do anything about traffic from one host in a VLAN to another host in the same VLAN. We can filter it, but not with an ACL. And getting into some nuts and bolts here about why we can't do that, it relates to the way an ACL is applied on a multi-layer switch. You know all about the CAM table. It's got our dynamic and statically learned MAC addresses, but it's the TCAM table, the ternary content addressable memory table, that cuts down on the number of lookups required to compare a packet against an ACL. Now, this packet filtering via switch hardware, we love it for one reason. It speeds up the overall process. We'll take that as often as we can get it. But there's one slight ding there. It limits ACL capability to the point where an ACL can be used to filter inter-VLAN traffic, but not intra-VLAN traffic. Filtering between hosts in the same VLAN requires the use of a VACL, a VLAN access list. There is still an access list involved, though. It's going to be used as the match criterion within the VACL. You'll see exactly what I mean in the following lab. Some of this sounds a little techno-babblish, I understand, but once we start writing, it's like, oh, okay, that's how it works. And this is exactly what we want to do, or what we're going to work with. We have three hosts connected to a multi-layer switch, and they're at the addresses 10.1.1.1, 2, and 3/24. What we want to do is not only block them from communicating with anybody else in this same subnet, we want to stop them from communicating with each other. We're just hardcore in this one. So let's go ahead and bring up the equipment, and you can see a couple of pings here I sent before the lab started. And you can see that host 3 could ping 1, host 2 could ping itself there. I sent a ping to itself. 1 could ping 3. So I sent some pings around. Everything's good there. Let's go over to 2. Ping 10.1.1.3. There we go. And now let's go to the multi-layer switch. So everybody can ping everybody right now amongst those three hosts. You always start a VACL by writing an ACL. And that's what we're going to do here. And we're going to use IP access list. And we need an extended one because we've got to define a source and a destination. And I'm going to call it block first 3. You don't have to use underscores if you don't want to. I understand a lot of people don't like typing them. But when you can, especially in a lab environment, give your ACL some kind of intuitive name. So if you go back and look at it 2 hours, 2 weeks, or 2 months from now, you say, what was I trying to do with this ACL? Oh, I was blocking the first 3 something, and addresses should follow. So let's go ahead and hit enter there. And we drop into NACL, named access control list config mode. And what we're going to do is a permit statement. And we're going to use IP naturally, and then you're doing your source address. What wildcard mask should I use here to match the first 3 hosts there, ending in 1, 2, and 3? I should use 0003 because my requirement is that these 3 hosts should not be able to send traffic to anybody else in the subnet. So the source of the traffic is either going to be 10.1.1.1, 2, or 3. Those are the 3 I want to affect. Now we got to put a destination in, and we know what that's going to be. 10.1.1.0, what's the wildcard mask? 0.0.0.255, because we're blocking access to everybody in the 10.1.1.0/24 subnet. So now, that's it. That's all there is as far as the ACL is concerned. Now we're going to write the VACL. And let's go ahead and start that with the VLAN access map command. And then you've got to give it a name, and I'm just going to call it underscore no123. And notice there's a sequence number option here. VLAN access map, then I gave it a name. sequence to insert to or delete from existing VLAN access map entry. I'm not going to use that because I want you to see what the default is, but I want you to know that option does exist. So now I need a match statement and then an action statement. And what I'm going to do, start with match. I want an IP-based match and address. And here's where you put the name of the ACL that you just wrote. It never hurts to go back up and check it. You can even cut and paste it if you want to. But it's block first 3. So now I'm saying, okay, if it matches the IP address that is matched in that ACL, I want you to take this action. I want you to drop the packets. As I meant to mention at the time, I know it seems odd that your ACL is basically a one-line permit statement, then of course the implicit deny. But the one line we wrote of that ACL was a permit statement. And you might have been thinking, wait a minute, I thought we were, denying traffic here. Well, the deny actually comes in the VACL. You're only using the access control list to identify the traffic the VACL will take action against in this case. So now, though, we need a statement for all the traffic that isn't going to be matched by block first 3. How are we going to do that? Well, let's drop back a level. And I'm going to go right back into it. And I'm not going to put any kind of match here. I'm just going to put an action. And my action is going to be action forward. This is really the VACL equivalent of the permit any statement in an ACL. What I'm saying with this 2-segment VACL is, if it matches that ACL called block first 3, I want you to drop it. Any other traffic, I want you to forward it. That's why I'm not putting a match statement here. Very important stuff there. So that's it. That's all there is to it. Now, of course, we're going to take a look at it. And you can see show VLAN access map, very handy command because, of course, the challenge of any ACL or a VACL is just making sure your logic flows from top to bottom. And here, it shows the VLAN access map called no_123. Then it's got a 10 there. Match clause, IP address, block first 3, action drop. VACL map or VLAN access map number 1, no_123. Then a 20, match clauses none, action forward. So that just means forward anything that hits that line. Those the 10 and the 20 you see there, those are sequence numbers. If you do not indicate what sequence number you want, if you don't enter one when you're writing a VACL, then it's just going to increment by 10, obviously 10, 20, 30. If you now realized, oh, I needed to block one more address, or you needed to make a change of some kind, if you wanted to add a clause between 10 and 20, you just number it from 11 to 19, and it's going to show up in the middle of that. Beats the heck out of writing the entire thing from scratch, believe me. So let's see, we have done what? We've written our ACL, we've written our VACL, we've checked that VACL. What do we need to do now? We need to apply that ACL because it's not doing anything right now. We're going to use the VLAN filter command to make that happen. Filter is the one we want. It even says apply a VLAN map right next to it. That's awfully kind of it. And let's see what our choices are. We could use a name, and I'm going to use no_123 again because that's the map that we are applying. So we've got no_123. So what VLANs are we going to apply it to? Well, that's what we put here, and we're going to apply it to VLAN list. You do have to type that in, 10. You do have the option, of course, as you see, to add the filter to all VLANs. And that's it. So I keep saying that's it, and then there's one more thing, right? So we've written our ACL, we've written our VACL, and then finally we applied our VACL. So let's go over to 2 now, and we'll just resend the last ping we sent, the one that went through, and you'll notice now it's not going through. We're not going to tell host 2 why it's not going through, it's just not going through. And that is a VACL. Let's just resend the last ping, 10113. That's it. Okay, I'm going to stop saying that's it. And then there's one more thing. But again, once you write a couple of these and get the sequence down, of course it's ACL, then write the VACL, then apply the VACL to the correct VLAN. You just have to get used to the logic of the match and the action, but it's very straightforward stuff. So we are done here now with VACLs. We're going to move on to a subject called private VLANs. Not scaring you or anything, but the vocabulary we use is different, and this is just different than anything else you've ever seen. So just take a bit of a break before you come back and we'll tackle private VLANs.